Module 4.2, Day 2, Adding Polynomial Expression. Content standard. Understand that polynomials form a system analog to the integers, namely they are closed under the operation of addition, subtraction, and multiplication. Language objective. Student will explain to a partner how to add two polynomial expressions. Modeling with polynomials. You can model any situation using polynomials. Sometimes you can model a new situation by adding two or more polynomials. For example, a company offers two services. The number of people using each service at a given time can be modeled by polynomials that use the same variable. The total number of people using both services can be modeled by adding the two polynomials. A box company owns two factories in different parts of the country. The profit for each factory is modeled by a polynomial with x representing the number of boxes each produces, solved by adding the polynomials. The model needed in each situation are provided. The first factory makes a profit of negative 0.3x squared plus 20x minus 500, and the second makes a negative 0.4x squared plus 25x minus 1000. What is the polynomial modeling the box company's total profit if both factories make the same number of boxes? That means that we will need to add these two, and then they are already lined up already. So then, and in standard form, so let's just add those. So this gives us a negative 0.07x squared plus 45x minus 1,500. Right, so let's go on to our next example. Example B, a company plans to open a third factory with a projected profit of negative 0.3x squared plus 50x minus 100. What will the total profit of the box company written as a polynomial if the projected profit is correct? The total profit for the first two factories mentioned is negative 0.7x squared plus 45x minus 1,500. The projected profit from the new factory is negative 0.3x squared plus 50x minus 100. So, right, so then we're going to solve this by putting this in a vertical form. Right, so when we add those, this gives us negative 0.1 x squared plus 95x minus 1,600. Okay, let's go on to our next one. So that your turn. Model various situations with the sum of polynomials. Simplify their sum. Okay, for example 10, a scientist is growing cell cultures and examining the effect of various substances on them as part of his research. The culture in one petri dish increases according to the expression t squared plus 4t plus 4 for time t in minutes. Another increases according to t squared plus 2t plus 4. He needs to feed all the cells equally, so he needs to know the expression for the total number of cells in both dishes because the food is proportional to the total number of cells. Find the expression. So then we have a t squared plus 4t plus 4 and t squared plus 2t plus 4. So when we add those, we have an expression of 2t squared plus 6t plus 8. Right, and then for number 11, a farmer must add the area of two plots of land to determine the amount of seed to plant. The area of plot A can be represented by 3x squared plus 7x minus 5, and the area for plot B can be represented by 5x squared minus 4x plus 11. Write a polynomial that represents the total area of both plots of land. Okay, so make sure that when you do this, it's always in standard form, right? and then combining like terms, so this gives us an ax squared plus a 3x minus 16. Okay, so then let's try number 5. So what algebraic expression must be add to the sum of 3x squared plus 4x plus 8 and 2x squared minus 6x plus 3 to give a 9x squared plus 2 minus 2x minus 5 as the result? Right, so when we combine these two, so this gives us a 5x squared minus the 2x plus an 11, but we need to add this by something to get to a 9x squared plus a 2x minus 5. So then we say that, well, to get here we need to add a 4x squared, and here we have a negative 2x squared, so then we need to add a 0, and we need to go from 11 to a negative 5, so that gives us a negative 16. So the expression we need is a 4x squared minus 16. Right, okay, so let's try number 13. A rectangular picture frame has the dimensions shown in the figure. Write a polynomial that represents the perimeter of the frame. Okay, so here the clue here is that the given is a rectangular picture, right? I mean that this side is also 5x minus 2, and this side is 3x plus 1. Right, so then first combine the x term, so then this gives us a 16x, and now combine the constant term. Right, so then a negative 4, positive 2, so they give us a negative 2. Okay, so then let's P be the perimeter, so then the perimeter is 16x minus 2. Okay, so similarly to number 9, right? Vincent is going to frame the rectangular picture with the dimensions shown. The frame will be x plus 1 inches wide. Find the perimeter of the frame. Okay, so then we can make a picture of this, right? Okay, you see that the frame will be x plus 1 inches wide. That means that each of these you will add an x plus 1. Right? The same thing here, you need to add an x plus 1. Okay, so then this will be a 5x plus 9, and this will be a 3x plus 4. And then it's a rectangular frame, so this is also 5x plus 9, and this is a 3x plus 4. So when we combine the x's, so this gives us a 16x, and our 4 plus 9 is 13, so that gives us a 26. Okay. So the perimeter of the frame will be 16x plus 26. Okay, so that's the end of our notes for 4.2 day 2. Your assignment is your book set, and to finish your HRW 4.2 and turn them in, and also copy down notes for 4.3 day 1.